Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do a very important lead code problem, and I have provided the introduction of what are the things to expect from this video. We are going to solve the combination sum problem, and first of all I'll be showing that what are the top companies that have recently asked this question from LeetCode Premium. We'll understand the problem statement, we'll also find the optimal solution, and we will also determine that what would be the intuition behind it. We will create an example and we'll walk through it, and at the end I'm going to write a Java code. I'm going to explain it thoroughly, that how we come up to it, and also we would be explaining the time and space complexity. So first of all, these are the top companies that have asked this problem recently, and if we see from past 6 months to a year, it's eBay, Google, Goldman Sachs, and these companies. And pretty recently, Amazon has asked this question 20 times in its interviews. Facebook has asked this question 18 times in its interviews. So I highly suggest you to take a look at this problem, understand it completely, and then practice it as much as you can. This is a medium problem, and we are given a distinct integer called candidates, and we are also given a target integer, and we need to return all the unique combinations of candidates where we can reach up to the target value. Now this is a little bit tricky part to find all the unique combinations for this target candidate, because let's try to understand this with an example. So over here we are given the candidates as 2, 3, 6 and 7, and we need to reach the value number 7. So we can clearly see that 7 is already present over here, so we can return this one. The thing is, we need to return all the unique combinations. So one unique combination is 7, second unique combination, and also one more thing, we can use the same number from the candidate unlimited times. So if we apply this theory, then we can find another value that can reach to the sum of 7, then that would be 2 plus 2 plus 3. If we do that, this also sums up to 7. So we need to return a list where the two values are 2, 2 and 3, and the second element is just 7, and this would be our solution for this given problem. Okay, let's try to understand this problem with a custom example. And it is really important to create your own custom examples, because it shows that you have the ability to think outside of the box, and you can create test cases on your own. It is a really important skill to have for any engineer, and especially FAANG engineers. So we are given three candidates, 2, 5 and 6, and we need to see that what are all the combinations we can get out of these candidates to achieve the target value 8. Now just by looking at it, we know that the two combinations we can create is 2, 2, 2, 2. This is one combination, and the second combination we can create is 2, 6, and this would be our answer. The thing is, let's see that what would be the most basic solution we can come up with, and what would be the intuition behind it, and based on that we would be able to create an algorithm that would solve this problem. So initially we are at this position 0. Now at this position 0 we have three possibilities from which direction we can go. We can either go to this value number 2, we can go to the value number 5, or we can go to the value number 6, and because these are the three candidates that we are given. And also we should not forget that the target value we want to achieve is 8. Okay, so keeping this in mind, we need to go and pick a side where we need to go further, and keep going. So again, let's just go on one direction for all the cases we can. So over here we are at 2. Now remember that we can use same element infinite times, which means that there can be one possibility as 2, 2. Of course, there can also be one possibility as 2, 2, 2. Of course, the thing is, notice that we need to put a constraint for the number of decisions we are making, and the constraint is that if at any point the direction where we are fetching all the candidates, if the sum of those can either be less than target, they can either be equal to target, or they can be greater than target. These are the three possibilities we can have. If it is less than target, which means that there is still room for us to find the potential combination, which means we can keep further going on that direction. If we are already at value number 8, or whatever target we are, we can directly put this value in the result. But if we and which means that we have found the combination, so there is no point in going further after we have already found the combination, because all the elements, they are only going to add up to whatever combination we have, which means that we won't be able to find another combination with the same numbers that were used to achieve this equal to. And the third option is that the value could be greater than 8. If it is greater than 8, why are we keep on going or to do more iterations and putting more strain in our computer? There is no point in doing it, because we could have infinite options, and if we do it, this would be like the most worst, this would be like the best way to deplete the resources of our company. So we don't want to do that. So now, since we have kept these things in our mind, now let's see that how can we use them over here. So far the sum we have found up until this point is only 2. But the thing is, over here we have 2 candidates, and the sum we have found so far is 4, which is still less than 8. This is 6, again still less than 8. Now over here we can have one more possibility as 2, 2, 2 and 2. And if we do the sum of this, this is 8, which means that this is actually equal to whatever the target value we had. So we can add this to our result combination. We would have that we have already find one value in our result, and we will just add it as 2, 2, 2, 2. This is one combination that we have found so far. The thing is, we are not done yet, because we still have other candidates that we need to look at, and we need to check the possibilities. The thing is, we have concluded at least one thing so far, and that thing is we can't go further down on this path, because all the values would be greater than 8, and which is not what we want. So the only way we can go is actually we can go back and see that have we missed out on any combination. So over here, the next possibility we can get is we have already used 2 as our candidate for this value 2, 2, 2. So the next possibility we can have over here is it could be 2, 2, 2 and 5, or it can be 2, 2, 2 and 6. So let's do sum of all the combinations. So some of these combinations would be 11, and some of these combinations would be 12. Notice that both are actually greater than the value of our target, which means that we can't go further down at any of these positions, and we have exhausted all the possibilities up until this point. So since we have already exhausted the possibilities up until this point, the only way we can go is we can go back. At this position 2, we have exhausted all the possibilities there can have. One, we found the answer, and the other 2 we found that it cannot be part of the combination, which means that we have already exhausted all the possibilities for this value 2 to 2 as well, which means that we can't go down, but we can go up. So over here, have we exhausted all the possibilities so far? No, there are still room, there are still other possibilities that we can check. So let's do that. So one possibility we can have over here is 2, 2, 2, which we already checked. The next possibility could be 2, 2, 5, and the next possibility would be 2, 2, 6. So sum of these values is actually 9, and some of these values is actually 10. Again, both are greater than whatever the target value we had, which means that we cannot go down. So we will go back. We went back. Over here we check that we went through all the possibilities, which means that we are done over here. So we can't go down any further on this path, but we can go up. So if we go up, we ask ourselves a question that have we explored all the possibilities at this position? No. The possibilities we could have is 2, 5, 2, 6. So let's take this value first. So at 2, 5, the current sum we have is 7. 7 is less than whatever value we have as our target, which means that we still have possibilities. The possibilities we can have is 2, 5, 5, or 2, 5, 6. Notice that over here we only had 2 possibilities where we can calculate it from. we did not had the possibility of 2 to 5. Why? Because we already calculated it for this portion over here. Remember, in the previous iteration we already calculated for this scenario, which also shows one very important property, and their property is that out of our candidates, whatever the candidates we are given, if we are at any particular position or any combination of positions, so whatever value we have as last, we can only use that multiple times, or we can use the values that come after it. We cannot go backwards because we have already exhausted those possibilities in an iteration before this, as I showed you earlier, that this we have already explored over here, and this 2 to the 5 2 5 we are exploring at this position 2, which means that the only combinations we can make up after this point is either 2 5 5 5 something blah blah blah, or 2 5 6 6 6 something like this, but we can't make like 2 2 2 5 because we already checked that over here. So, and this is a very important property that we are going to use. Okay, at this point the sum we can have is 12, which is greater than 8, so we can terminate over here. We can't go down any further. And over here the sum would be 13. Again we can terminate over here. We can't go down, which means we have to go back. So we come back at 2 5. We say that okay, we have explored all the possibilities over here. We go back to value number 2. Now the thing is, at value number 2, have we explored all the possibilities? No, there is still one possibility pending, which is 2 6. So at 2 6, this value, the sum would be 8. Again, this is really critical because we have found a pair that equals to whatever target value we had, which means that we will add this combination to our result list. So over here we will add another entry 2 6, and after adding this, we have explored all the possibilities after this point, which means that we would go back. Now at this position 2, we have explored all the possibilities it could have, and because we have explored it, we will again go back to our 0th position. The thing is, we are still at 0th position, so can we stop now? No, we can't stop because we still have a whole lot of possibilities that we haven't touched so far. Because remember, over here we still have this 5 and 6 pending. So let's see that what could be the possibilities over here. Now at 5, again we can only have two possibilities. As explained earlier, we could have either 5 5 or we could have 5 6. So let's do the sum of these values. So 5 5, the sum is actually 10, and 5 6, the sum is 11. Both are greater than 8, which means that we can terminate over here. So that concludes that at this position 5 we ran out of the possibilities. We went up. At this position we are done. So again we go back. At 0th position. We check that do we have any other options where we can explore, and yes, currently we are at value number 6. So 6 is again less than our target 8, so we can go further from 6. The thing is, at 6 we can only do 6 6. We can't do any other combination because those we have already checked so far, which means that 6 6, the value is 12. So 12 is already greater than 8, which means that we can't go further from this, which means we can't go further. We go back. At 6 we see that have we explored all the possibilities? Yes, we have explored all the possibilities, which means again we go back to this position 0. So at this position 0, we check that now have we explored all the possibilities? Yes, initially we check all the possibilities for the value 2, again we check for value 5, and again we check for value number 6, which means that even at 0th position we are done. So our base case has satisfied. Now whatever we have stored in our result result list so far, we can simply return this, and this would be our final solution. And this is actually the optimal solution that we can achieve. Notice over here that we were doing lot of repetitive work. At any position we were calculating the different possibilities we can have. We were picking a possibility, we were exploring in that direction, depth first search. We kept on exploring. Once we found a terminating case, once we found Once we found a terminating case, we would go back to a point where we can still explore for more possibilities. Over here again we would further go down to additional possibilities. We would find a terminating case, again we would come back, and eventually we would come back to the 0th position from where we started, and after the calculation we will return our result. So this, where at any point we are coming back from where we originally started. This is actually called backtracking. This is a really important concept in computer programming, and I just showed you that how can we use it, and that is why, because this concept is really important, it has a lot of very practical applications, and that's why you see that why all those big companies like Google, Facebook, Amazon, Goldman Sachs, they were interested in asking this question to their candidates, because they want to know that are you familiarized with very important things that are really critical, and can you go down that path. And yeah, so since we have found our optimal solution, I did not mention explicitly that I was showing you the optimal solution, but the thing is, I told you that this is the intuition behind it. And once we knew the intuition, we just need to find a way to implement it in computer programming. The way to implement this, you must have guessed it correctly, that we were doing so much repetitive work again and again, and we were using it somewhere, and we had some terminating conditions that either if the value is equal to or greater than our target, we would terminate, which means that we were using recursion at its best over here. So yeah, this is basically our solution. So let's calculate the time and space complexity. That time complexity for this one would be big O of n to the power t. Now first let's determine that what this n and t means. N is actually the number of candidates and the least value for this one, and t is actually the total amount, because imagine that what could be the longest sequence we can have at any given position. Well, suppose our target value is 8 and our candidate is 1, which means that we would do 1 plus 1 plus 1 up until 8 times till we get the value 8, which means that we need to go in one direction 8 times, and at any position we can have multiple options or we can make multiple decisions, and from further down we can go ahead, which means that we need to do this work n to the power t times until we find the solution. So that's why this is the time complexity. So first of all, we'll create our result list, and now we'll create a list to store the current combination. Okay, now we'll create a backtrack method, and in this would be our recursive method. So initially we are going to provide the target result combination 0 as the starting point and the candidates array, and after whatever the result we get back from that recursive call, we simply need to return whatever we find in this result list. So let's create the recursion method. Okay, so first of all we are going to create the terminating cases. So if target is equal to 0, which means that we have find a combination that sums up to the target value, so we can just simply return it to we can simply add the combination to our result. If this is not the case, we need to return we need to check that whether the target is less than 0, which means that we have already surpassed our target and we need to break. So we can just return null. If both cases are not true, which means we still need to look for our combination. So we'll start by checking in our combination from the position start, and we'll go until we still have candidates. Now inside the loop, first of all, we will add whatever candidate we are currently looking for in our combination list. Okay, after that we can do our recursive call. And as a target, we will have target minus whatever candidate value we found. And start would be ith position. And I think that would be it. Yeah, one more thing, we will have to remove the entry from our combination list, because we will be doing backtracking when we move towards the next value. And I think this would be it. Let's try to run the code. This should have worked, but I don't know why it's not working, so we'll just enter the value manually. Oh, it should be candidates. Okay, our solution seems to be working. Let's try to submit the code. And yeah, our solution works perfectly fine, and I would be posting this code in the comments. You can check it out from there.